We can't discuss that. That's the very first thing on the recording. The recording has started. We can't discuss that. Now everybody can take the duct tape off your hands and let's relax. The second thing you hear in the recording. Okay. Okay, so I think right now we have so right now we have two things both getting parsed down to the same intermediate language, right? Now, I think I probably started saying this at the end of the class, but what does this remind you of? Jake, will you shut the door while you're over there, please? Thanks. What does this remind you of? Let's get back to an example of some languages. Who? Who? So let's take a language like C#. And let's take another language like Visual Basic. Technically, it's VB.net. All right. So, how many of you have ever written C# code? Like anybody who's had the software engineering class, don't you do C# in there? Who's ever written anything in VB? Couple people. Okay. Are they different programs? I mean, you use Visual Studio for both of them, but I mean, they're clearly different languages, right? Would you say they're even more different than Simon versus Beaker? Okay, so when we compile, now C#, high level, general purpose, modern day object-oriented programming language? Is it a compiled language? What does it mean for a language to be compiled? Compilation is a translation between what? High level to low level. Okay, so when we compile C#, what low level language does it turn into? C. C is a high level language.
Or does it go straight to machine language?
Machine language is machine language. So here we can put that all the way over here. Ultimately, we're going there. This is the end of the roller coaster ride. So when we compile C#, it's going to compile into a low-level language. What is a low-level language? One-to-one relationship. So every instruction in a low-level language translates into exactly one instruction on the CPU, one magic trick that the CPU knows how to do. Okay, so we compile C#. C# compiles down to what? C# runs on what kind of processors? Intel processors, right? So x86 assembly language. So usually we just call this assembly code, right? Okay, but notice I have this kind of far down the line there. It's also near the end of the roller coaster. This is where that one-to-one relationship happens, right here. So this is ultimately the CPU. And this is the assembly code. So every line of this translates into exactly one magic trick on this guy. But there's some crap here in the middle.
Would it only be x86? It could be 64 as well.
You're confusing 64 versus 32. That's different. x86.
Oh,
86 is the architecture.
Yeah.
So like the original Intel processors were the x86, then it was the 286 and the 386 and the 486, and Pentiums were the 586. So underneath the hood, there's the serial numbers for those. I think it's, I'm guessing we're on 986 now. It's possible they just dropped it. So now we just kind of call it assembly code. That's the Intel whatever low-level language. Okay, but I've left some space in here for some more artistic representations. You ready for it, Dane? It's called, what is the, splash painting? Splash painting parentheses. It's kind of, you gotta get, it's like a boomerang type of movement. Okay, so C#, we compile it. It does not compile into assembly code. It compiles into something else. What does it compile into? Probably saw this in the 250 class. So I believe everybody in here had 250 with me, correct? This was early on in 250 when we were talking about the difference between Java and .NET. What's the benefits of Java? So if you had to point to one thing that Java is good at, what would you say it is?
Runs on a lot of stuff.
Platform dependence. Write the program once, it runs on anything that supports the Java virtual machine, right? So Java programs, they boil down to, they compile to Java bytecode that then gets interpreted for the processor. As opposed to C#, which is the Microsoft language. Microsoft said, hey, you know what? We really, really like the idea of Java being platform independent. But we tried to steal it and got sued and lost. So we have to change directions a little bit. We're going to create our own language, C#. Except now we're going to learn from Sun Microsystems mistakes, and we're going to actually create a language that is platform independent as well without being slow. Why is Java, which is platform independent, why is it also slow? It's interpreted at runtime. It's compiled before runtime, compiled to Java bytecode, but at runtime, that Java bytecode is interpreted by a Java virtual machine, which translates between bytecode and real assembly language during runtime. That makes sense? But .NET doesn't work that way. C# programs, here, maybe this will jog your memory. .NET is platform independent on any platform that supports the .NET component architecture, which basically means that .NET is platform independent as long as you're running Windows. It'll run on any platform as long as it's Windows. That's the punchline. So C# actually compiles down to something called Missile Code, Microsoft Intermediate Language. And guess what? So does VB. Then both of these guys go through something called a just-in-time compiler, JIT, that translates from this low-level language to this low-level language. So that at runtime, it's running directly on the architecture, directly on the hardware. That make sense? And this is actually one of the interesting features of .NET programming, is you can write part of your application in C# and another part of your application in VB and have them work seamlessly together. You can instantiate VB objects inside of your C# programs. Now, I'm not sure that's necessarily really a feature, but it is a kind of an interesting trait of .NET programming. You could maybe make the argument that it is a feature from the perspective that some things C# might have some built-in libraries that are easier to work with than VB's, some built-in libraries for the similar things. Maybe C# networking stuff is more robust than VB's built-in networking stuff. But maybe VB's front-end graphic user interface design stuff is easier to work with than C#. So you might write your whole user interface in VB and then your back-end networking aspect in C# and have them all work together. Just as an example, I don't think it's that common to have somebody write a mixed language application. But you could, is the joke here. Okay, so we see this model right here, right? So I'm going to copy this. That's Simon. That's Beaker. Now we need to name our own intermediate language. What are we calling that guy? That go ahead.
Yes. Intermediate
Beaker Simon. Yes.
language.
BSIL.
Go with that one.
Is that Basil code?
Sure, we'll go with that.
go with that. Bissell code. Basil code. I like Basil. Isn't that from movie?
Which one?
What's the guy's name? The guy from Wayne's World.
Little Wayne Garden.
Little Wayne.
Well, no, he's what are the name of the the other one? No, the name. What is the name of the movie? He lost his mojo. Austin Powers.
Jeez.
Oh, we're going on that road.
Yeah. So he's the guy's in Austin Powers, and isn't the like the lead British intelligence guy's name is Basil? Basil.
Yeah.
See, that's where I'm going with this. So this is Basil code. Okay. Now we have an option here. Would you guys like to write a just-in-time compiler, or which ultimately translates something from a Basil code into assembly code, and then runs directly on the CPU, or would we rather replace these two steps with an interpreter? Trust me, you think you hate me now. You want this to be an interpreter. All right, and that will ultimately run on the CPU. So actually, our model will look like this. Oh, hello. So we're going to write a Basil interpreter in terms of scheme. So these guys kind of meld together. That makes sense? All right, so understand the difference between parsing and interpreting. What we've written so far is something that takes in a source language like Simon or Beaker, parses it down to a data representation that we've named Basil code. Now we need to actually interpret this Basil code into actual working program. If we write a if statement, an if statement has meaning, we expect it to do something. At this point, our entire language is about data representation. We can't do crap. All right, kind of makes sense where we're going with all this? All right, so let's see if we can find ourselves a 5-star.
That's a nice 1-star.
I want to get down to apply. I don't even go. I don't want to go that far yet. All right, so this is what we're going to do. Just as a reminder here of what this guy actually looks like. It looks like we already had it in there, but we'll. Okay, so this is what our language kind of looks like. It's a collection of lit expressions, var expressions, app expressions, and lambda expressions, although I don't see one of those in here. Do we have one of those in here? Yeah, lambda expressions. All right, so that's what this guy's a collection of, and I'll just go back up here to our BNF for this. So lit expressions, var expressions, if expressions, lambda expressions, and app expressions. That's our entire language. So we know how to do those types of things. Now, let's say that we have a lit expression. A lit expression is just a number. So if I pass in a 5 and I want to execute a lit expression, what would it execute to? In Java, if you just say 5, what would the output be? It's a literal. 5 in Java is what? We're going to pass that through all the cogs and gears of Java, and it comes out the same, comes out the other end, all magically transformed into a 5. Right? It's a literal. It doesn't change. It's a hard-coded value. So if we want the results of executing a lit expression, we are left with whatever the expression was. Done. Easiest one to execute is a lit expression. All right, so we're going to create something called apply expression. Come back up here. Apply expression is going to be a lambda that takes in Basel code. Okay, so our data representation. And we'll leave it at that for right now. We're actually going to add something to that before long. Okay, and we know that Basel code looks something like this. It's lists of crap, right? Now, when we run a program, what do we expect the answer to ultimately be? Crap, exactly. All right, well, let's start this off simple. Simply. So I'm going to create a cond. We're actually not going to do the null thing yet. So I'm going to create a cond, and we're going to say if the car of Basel is equivalent to lit expression, then we want to boil down to the value stored within that. So here's an example of our lit expression. Lit expression would look like that. So if the car of that list is lit expression, we want the catter. That make sense? We'll boil down to the catter of my Basel code. That's what it means to execute a lit expression. So in Java, 5 boils down to 5. Make sense? Okay. Now, next kind of expression. We have a var expression. So let's say we had a var expression. For instance, this guy. What should that guy boil down to? What's a var expression? What does the word var mean to you? Variable. So if I have a variable named a in Java, what does a boil down to? the value contained in A. So I need to dereference. I need to resolve that variable. How do we resolve variables? Okay, tell me more about that. I mean, I agree, scoping is involved, but ultimately, how am I actually resolving a variable? If I have an A, I'm looking for where that A is most locally bound, correct? That's the scoping rule stuff. Once I find it bound somewhere, what do I need to do? I need to get its value. How is its value stored? Okay, I agree. We've actually created a construct here before. Didn't we create a variable environment? Wasn't our variable environments lists of, it was a list containing lists of variable names, correct? Kind of in scope order. But then we enhanced that a little bit. We started talking about variable types, and we talked about variable values. So at the very least, when we think about variables, a variable has a name and a value. Let's forget about types for a little bit, because this is going to be scary enough. So we need to now create a variable environment. Oh, what does an environment look like? Well, we've sort of already seen one of these. Let's actually do this in variable environment. So a variable environment might look something like this. So this would be the empty env. So that might be the empty list. What if we had, so that's the basis for it. You're going to start seeing this thing look like a BNF here real quick. Okay, so that's the empty BNF. Or it's what? It's a list containing let's call it this. I want to represent my BNF. Zero or more scopes. And actually, if you're going to have your first thing be the empty list, you would probably say one or more scopes. Where a scope is what? So a scope is a list containing var zero or more var val pairs. Didn't somebody teach me how to do this? Shift tab. Oh, there we go. Well, what's a var val pair? A var val pair is a list containing, we'd actually probably just call this a symbol and let's call it a number. We'll say for our simple case, our variables can only hold numbers. The math language. So we can have the empty environment, that's an environment with zero scopes. Or we can have an environment that is a list of one or more scopes. So you could even say that an environment is a list of zero or more scopes. Where a scope is a list containing zero or more var val pairs. Where a var val pair is a list containing a symbol and its value. Variable name and the value of that variable. That make sense? Okay, so an example of an environment might be So if we have just a local scope, an example might be A is 5, B is 7, C is 8. Something like that. So we have a single scope in here. That's our single scope. So we have an environment, which is a list containing 0 or more scopes. So in this case, we have one scope. And that one scope has 3 var-val pairs. First var-val pair is this guy right here, A and 5. Second one is right here, B and 7. Third one is right here, C and 8. Make sense? Okay, so working with variable environments. We need to have the ability to create an environment, add crap to the environment, look crap up in our environment, and get values. So what are all the abilities of our environment? If we are writing, see what we're doing is we're adding our data representation language. We have this data representation language. We're talking about executing it now. But now, in order to execute it, in order for it to even make sense, we need to have the ability to store variables, real variables. So we have to write the variable system into this. So let's go way, 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 way back to the very, very beginning. God created the heavens and the earth. Point. All right, so way back at the very beginning of this, remember we talked about, this is probably in CSE 200, that programming languages give us, mimic the way human beings solve problems. The first of those ways is memory, that we simulate through variables. So we need to create programmatic implementation of how variables work in our language. So what do we need to be able to do? We need to be able to create an empty environment. We need to be able to add scopes to an existing environment. We need to be able to add var-val pairs. Actually, let's not get even that detailed. Let's just keep it at the high level. Create an empty environment, add scopes to an existing environment, and then resolve a value given a var name, or given a symbol. Does that make sense? So at the high level, that's what we need to be able to do. We need to be able to store it, and we need to be able to retrieve it. Let's come back out here. Let's close off our apply expression. We can't go any farther now because we can't resolve variables yet. So our var expressions are kind of a dead end for us at this point. So we need to define empty env. What's an empty env?
One or more scopes.
Empty list. It's got to be a starting point. We have to have a beginning. So our most basic environment is the empty environment. That make sense? Everything else is an evolution off of that empty environment. Okay? So now we need to have a function that allows us to add a scope to an existing environment. Well, how do we build a scope?
variable environment instead of another variable environment.
Okay. So we need to make a decision here. Let's go this route. Is it fair to say that our variable environment is a list of scopes? It's a list of 0 or more scopes, where each scope is a list of var value pairs. So if I had the empty environment, which is just an empty list, that is a list containing no scopes, and I want to add something to it, what is that something? What is the something I would add to a variable environment? A scope. It would be a scope. So I'm gonna add a scope to it. And what's a scope? A scope's one of these guys. Can I build a scope? Possibly. This is actually going to be funny here in a second when you see how weak our current language actually is. So we'll start off with the empty environment. Then we're going to do define add scope. And this is going to be a lambda that takes in an existing environment and a new scope. And what's it going to do with that scope? Scope is a list of var value pairs. So what do I do with that scope in order to add it to my existing environment? Cons it on. Con scope onto env. So there's add scope. Make sense? Okay, so if we even just test those two things. I'm going to say add, did I do add dash scope? Is that how I did it? Yep. And I'm going to pass it an initial scope, so we're going to say A5, B6 onto the empty environment. This boils down to a list containing a scope. There's my scope. Make sense? If I were to then add another scope, C5 onto the environment that's returned by adding scope A5, B6 onto the empty environment, I get an environment with two scopes in it. Here's the first scope, and here's the second scope. Make sense? Simple little environment. We're going to see it has some limitations before long, but for right now, we can kind of follow this, right? Okay. So we can create an empty environment. Got it. Check. Add scopes to an existing environment. Check. Now we need to resolve a value given a symbol. So we need to define, let me get some spacing in between these. Resolve var to be a lambda that takes in a symbol and an environment. And it's going to go through that environment and return the value of this variable. And the value of this variable is what? Its value in the most local scope. That makes sense? The most local scope. That is, if I pass in an A here, modify my environment down here a little bit. So let's say this is the representation of my environment. And I've actually defined A twice. I have A in my most local scope, having a value of 3. And then I have a little bit more global version of A that has a value of 5. If I were to resolve A inside of this environment, what should it resolve to? 3. The most local definition of A, which is this guy right here, not this guy right here. That make sense? So we need to find the most local definition of it. And it just so happens that our environment is storing things with the most local scopes first. Make sense? Okay. So, how am I going to resolve this? Let's have it boil down to a false if it can't find it. So if I'm still kicking, we'll do a cond here. If null env, if I'm looking at the empty environment and I'm still kicking, that's the best I can do, buddy. And we're okay returning a false since right now we can only hold numbers. Eventually, if we can hold other types like Booleans, returning a false isn't going to cut it. We probably need to have, at that point, we have a language that's complicated enough that maybe we throw an exception. Variable not defined exception. That kind of stuff. Okay, so only if we're dealing with a null environment do we return a false. Otherwise, we still have places to look. So if I'm not dealing with the null environment, the car of my environment must be a what? My environment is a list of what? It's a list of scopes. If I have a list of scopes, and it's not an empty list, the car of that list of scopes, you'll probably still miss it, Simon. The car of that list of scopes is what? Actually, that's true. It's not quite the full answer yet, but so far so good. Let's keep going. I literally threw up my coffee cup if you saw that. I have calluses on my tongue for as much coffee as I drink. What's the name of the show? It's on TV right now. Oh, it's called Dads. Have you guys seen this TV show? It's about these two guys who run a video game company, and they're comedians. You'd recognize the guys, and their dads have moved in with them, and they're just making their life a living hell. Well, one of the episodes they had this new human resources lady that got hired there, and one of the two guys are just pigs, always hitting on other women at the office and stuff like that. Well, anyways, this new human resources lady comes in, and everybody's afraid of her. She comes out to get a cup of coffee, like at the beginning of the morning. Comes in. I mean, this coffee, you just heard people complaining about how hot the coffee is. She pours this whole cup of coffee and just chugs it like it was nothing. And just walks away. It's like, did you just see that? That's me. I'm a coffee chugging human resources lady. Answer the question, Simon. The scope. Who told you? Coleslaw? Did you tell him?
No.
Really? You came up with that on your own?
Yes.
So proud of you, Simon.
Cool.
Gold star for the day. All right, so the car of my environment, this guy right here, will be a scope. If I have an environment and it's not the empty environment, I must be looking at something whose car is a scope. Now, what's a scope? What's a scope?
Our valve here.
A list of var-val pairs, right? So what is the most simple case that this guy is? He could be the empty list, couldn't he? Couldn't we have an empty scope? That is a scope that has no variables defined in it? So car VNV could be an empty scope. Well, here, we'll see if you guys can figure it out. So I need to now look for S, this variable name, inside of this scope, because this is my most local scope. This is the next place for me to look. How do I look for a variable inside of a scope? Oh, but a scope looks like this. That's an example of a scope. It's a list of var value pairs. Do we probably need a helper function? Okay, so maybe have a helper function that we pass a scope to, and we process that scope. So let's call this guy define process scope. This guy is going to be a lambda that takes in a symbol and a scope. If we're out of var-val pairs to look at, and we're still kicking, let's return false. I did not find this variable in this scope. Make sense? Otherwise, I may have found the variable in the scope. How do I know? If I'm not looking at the empty scope, the car of that scope is what? A var-val pair. Okay, so if I'm not looking at the empty scope, the car of that scope is a var-val pair. Where a var-val pair, so the car of scope, is a single var-val pair. How do I say, does this var-val pair's var equal S? Car of the car? C-A-A-R? Give me the car, which is a list, then give me the car of that list, which is the variable name. Let me demonstrate down here. If this is my scope, and the car of that scope is a var value pair, the car of that var value pair is the A. That make sense? All right. So if the car of the scope is equivalent to S. So if the variable name I'm currently looking at is the same as the variable name that I'm trying to look up, then I want to boil down to its value. Correct? All right. And how do I get its value? This is the car, and this is the cooter. It's the car of the car. No, car of the cooter of the car. All right. Take the car as that guy. Take the cooter, the CDAR is that guy. CADAR. So I'll return the CADAR of scope.
Why isn't it just the cooter of the car? Oh, that would be.
So if that's the scope, car is this. The cooter is that. and then the car is that. So I want the car of the cdr of the car. CADIAR. Or we could just use our list ref. List ref 1 of car. Well, this is too much fun. All right, where am I at here? Okay. So, if I found the variable I'm looking for, go ahead and return its value. Done. Otherwise, I'm not looking at the empty scope. And the variable I'm currently looking at, the first var value pair, is not the variable I'm interested in. I need to call process scope passing it the what? The cdr of my current scope. Everything but the car. But I also need to pass along s, the variable I'm looking for. Make sense? So, now we're back to resolve var. Resolve var takes in a symbol and an environment. If we're dealing with the empty environment, I've looked everywhere and can't return crap. So, I'm out of places to look. False, you deal with it. Otherwise, if the car of the environment is a scope, and I have a function called process, I have a function called process scope that takes in a symbol and a scope. I can call that. And now I'm interested in whether or not that guy returns a false. But that's actually redundant to say is false equal to false. What I really might want to do is I might want to say not this. Okay? But we'll leave it at the redundant one. It'll be clearer for us to follow. So, if whatever's returned by process scope is equivalent to false, that means I looked for the current variable in the scope and I couldn't find it. So if I looked for the current variable in the scope and I couldn't find it, what do I do? Go to the next scope. Now, I'm actually going to change this up just a little bit. That's actually right. Absolutely right. We can go to the next scope. But if my process scope does not return a false, it will return a what? Because I have a language that could only hold what kind of values? Right now, my variables can only hold numbers. Right? This is a language of numbers. I'm only allowed to store numbers. Can't store letters, can't store phone numbers, just as a single number. Can't store strings. So what I might do is I might say if process scope S and the car of the environment, if that guy's a number, if he ultimately returned a number, my job is done, right? I found the answer. I found the variable that I was looking for, S, and I have its value. What's its value? It's what's returned by process scope. So what do I do as a result of this? If that guy returned a number, what will I do? This is inside resolve var. Resolve var's job is to return the number associated with the variable. How do I return that number?
of variable.
You're overthinking it. If this guy right here, this guy right here returned a number, the number he returned is the value I want, right? It's inefficient, but just call that guy again. It's like, look, I know that you have the value I'm interested in. I'm going to actually kick this down the line so we can see. All right, so if process scope on the first scope, or the next scope is maybe the better way of saying it, passing it S returns a number, then call process scope again, and let's get that number. Else, if I'm not dealing with the empty environment, that is, it's an environment with at least one scope, and I didn't find the variable I was looking for in the current scope, in the next scope, what am I going to do? Look in the next scope. Look in the next scope. So I'm going to call resolve var, passing it the same symbol and passing it the cdr of env. That make sense? I'm going to keep calling it over and over again until I finally either get an answer or get a false. So that's resolve var. And resolve var is written in terms of process scope. So let's go back down to this guy. I'm going to say define my env to be whatever's returned by this. So if I type in my env, I get this environment. So I've stored this environment inside of a variable called my env. So now if I say resolve var a in my env, what should the answer be? 3. Here's my 3. I found it. Resolve var, let's stick with this. B in my env should be what? 6. Resolve var C in my env should be what? False. There's our false. So if we go back here, we already saw that it worked on the most local scope. If I change that guy back to C, now I should get the 3 for C. And if I go to A, I should get the 5 for A. So now we have a functional variable environment. That make sense? Still, all dealing with data representation. It sounds like we're solving a more complicated problem. We're just processing a list of lists. A list of lists of lists. Okay, so now I have the ability to look up a variable. So since I have the ability to look up a variable, I can now go back to my apply expression and say if EQV car Basil is a var expression, if I'm looking at that, what will I do?
Resolve.
Who?
Resolve.
Resolve var. Okay, so I'm going to call my resolve var method or function. Okay, resolve var takes what as a parameter? All right, let's deal with the symbol first, and then we'll let it hit the fan. All right, so I did say it. Let it.
Got it.
So we're recording. Well played. Okay, so resolve var what? Resolve var, we're going to go ahead and get the cdr of Basil. That's the variable name. But I need to look it up inside of an environment. I don't have an environment. When you first start a Java program, do you start with the empty environment and then build onto it from there? Yeah, realistically, you start with the stuff built into java.lang, but bottom line is you start with an environment that you didn't add crap to. You start off with some sort of baseline environment. Then as you start creating methods and defining variables and things like that, stuff gets added to your environment, right? So realistically, apply expression really needs to take in an environment as well. Does that make sense? We have to have an environment that we are operating within for the current scope. So I'll call resolve var, passing it the catter and my environment. But now we have a problem. Assuming we have a assuming we have a var expression, which is a variable name that we would like to resolve. How can our language ever allow us to get a value added to our environment? See, now we got issues. We're getting ahead of ourselves with our language. Our language is so simple that we've just written a mechanism for looking up values for variables, and we've never given ourselves a mechanism for defining a variable. We can't create variables inside of our language. All we can do is we can have a hard-coded number. We can have a var expression, which is basically just saying, give me a variable name, I'll fake it. We have the ability to do an if expression. Let's not even get into whether or not we can deal with Booleans. We have this ability to do a lambda expression where we could take in a parameter list of unresolvable variables because they weren't defined anywhere. Right? And then we have an app expression that just starts the nightmare in bulk. So if you were adding another expression in here, if you were adding a feature to our language to allow us to define variables, maybe a var def exp, what would that look like? Did we decide whose language was better, Simon or Beaker? Because you don't want to have to come up with two separate syntaxes for this. We need to come up with a universal a universal syntax. So the whole point of last class was to bring us to the realization of this slide. Okay? But now we have to pick a winner, because we're not going to evolve two separate programming languages. I'm having the feeling that the stuff we're dealing with right now is probably hitting many of you pretty high up on the forehead. Simon's over his head, but it's high forehead stuff for some of you right now. If it's hitting somebody in the knees, that's good. Anybody getting hit in the knees with this? So what do we want our syntax to look like? There isn't like a right or wrong answer to this. It's like, hey, by the way, our Simon language looks like this, and you know what? Fine, we're just going to do this. What just happened? We killed off Beaker. Beaker language is gone. Sequels are never as good as the original. which means we also don't need unparse. Where is unparse? Oh, yeah, we didn't need to, right? Okay. So we have parse Simon and we have unparse Simon, and so we're good, right? We need to get rid of all existences of Beaker. Okay. Well, hold on. We are allowing you to remain in naming rights only with the Basel expression. See, there were two original founders. One of them got out of line, so it took him out. But, you know, he does represent the first character, Charat Zero. Man, it sucks that you already have a nickname. You could be Charat Zero. That could be a nickname that could catch on. It sounds stupid right now, but I hit something hard enough over and over and over again, all of a sudden you'll be signing your test with that. Charat Zero. Like, I had a student back at Western Illinois University, and he was kind of I don't know, he was out there. You know, kind of out there. But his nickname was Mod 6. Actually, it was this class. It was this language theory class there. And we were doing some sort of thing, and he was coming up with this, like, strange solution to some problem where he, like, yeah, just mod it by 6. So I mean, it was, like, from left field. But you think he wasn't stupid. Like, you know, he wasn't like Simon. He was, like, way, you know, it's like way better. Now the funny thing is Justin was complaining that I was giving him a hard time before class. You're not as fun in class. Before class, you got all this attitude. In class, you just
skipped all last week.
Yeah, and then he's sitting there asking Tina what happened in class. There was better resources. Anyways, what was I talking about? Oh, yeah. So, anyways, he was modding something by 6 as part of a solution, and this was like before projectors. I was writing on the board, like chalk. This was a chalk-based board. So from that day forward, his nickname was Mod 6. I've had World of Warcraft characters named Mod 6, and I'm playing that was it the virus game, Plague Inc. on iOS. Yeah, I got him into it.
Has an iPhone.
Yeah, the name of my name of my plague is called Mod 6. Kills off humanity over and over and over again. So, anyways, in Simon syntax, let's say that I was defining SE7. Why did I pick 7? Because I skipped 6 out of. It's an act of solidarity. I actually don't know why I did it, but we're sticking with it. What would a defined var expression look like? So let's say we're trying to say a is equal to 5. Let's say we're trying to accomplish that. How would you say that in Simon? There is not a right or wrong answer to this. Well, there's probably wrong answers if you say something really dumb, but I'm asking you what your preferred syntax would be.
Variable equals reference.
Like that?
Go space.
Okay. Now we have a chance to make fun of coleslaw. So you want to say what, A5? Or you want to say A equals 5?
I want to say 8.
You want to say that? Oh, even better. Okay, so this is what you would do in something like Java, right? Well, Scheme is a Lisp. Lisp. It actually is a superset of Lisp. So what I said is actually intelligent. Scheme is a list-based language, and typically we have things that look like app expressions. So just like we had lambda this, or we had if this is true, do this, otherwise do this. Does that make sense? So we'd probably represent this differently. Maybe we'd say, let's well, we could do a single equal sign, kind of like off of taking Java's assignment operator as the example, as opposed to equivalence being double equal sign. So we'll take the assignment operator A5, like that. So that might be how we define a variable named A and set it equal to 5. That seem fair? Okay, and this guy is going to be a make sure all my code still runs here. Oh, this is going to be so entertaining. So this is what it looks like, right? A var def expression. All right, let's talk about some homework. This should actually be a very, very, very easy assignment. Like some of you, it will take you 5 minutes to do the whole assignment. It's just one of those things that looks like it's like the worst parts of the Bible. I'm up to like 7, 8, 9 points in one of my other classes. Is this 470? Man, it's such a high number. I'm making this class too easy.
Give them, say no. We could drop some other class this assignment.
No, you want this assignment. I promise you, this assignment is easy.
Okay.
You should be scared right now because it seems so overwhelming. But you are literally going to have to write like a total of like 2 lines. Total.
Can we sue if that's not true?
Okay? Well, everybody should pay attention so you know what I'm asking you to do. So update, parse, Simon, and unparse Simon to support var def expressions, where a var def expression looks like equals a 5 in Simon syntax and var def expression A5 in parsed Simon. That makes sense? And then I'll give you all that code to start with. Go ahead.
Can you put the parse Simon and unparse Simon in there?
I literally just copied the entire thing. You have everything.
Oh, I guess I thought you.
Yeah, I gave you everything.
Oh, okay.
You got unparse, you got parse. I gave you the starting point. You just have to add something to your cond for both parse and unparse. That make sense? And you have 4 minutes left in class. Some of you may finish this.
My computer has no batteries, so.
That's the reason.
Otherwise.
This is due on Thursday. Is that today's Tuesday?
Yep.
Yeah, so it's due Thursday.
This is a behind the scenes look.
It's worth 1,000 points.
Yeah.
Now, just out of curiosity, how many of you at this point recognize how easy this assignment is?
I don't have a clue what this assignment is.
The rest of you, I'm not kidding. It really is simple. So just sit there and think through it, and you'll recognize how easy what I'm asking you to do is. Just copy one of the other cons that are in there and just modify it slightly, and you're done.
I really hope I figured out how I'm going to feel really dumb.
I expect half of you. I expect half of you not. That way I can make half of you feel dumb. See, Dave's like, look, I'm not even gonna look at it. I'll put some time into this. Put some time with some parentheses. All right, I will see everybody on Thursday with completed assignments. And remember, if you have questions, ask. You have my cell phone. You have all the other ways of getting a hold of me.